Welcome to the School of Life. Life is hard, but you have got to be harder. I'm Mrs. Collins, your life coach. Let's get started with Unit 3, Lesson 4, Quadratic and Cubic Functions. In this lesson, we have two essential questions. The first one, how do transformations affect the graph of the quadratic function family? And the second, how do we analyze and graph cubic functions? So we're going to talk about both quadratic and cubic functions. You will notice that there are some similarities, but there are also differences between quadratic and cubic functions. We'll start off with quadratic functions. And we're going to start by graphing the parent function. So this is the very basic quadratic equation that we can, or quadratic function that we can actually graph here. So we're going to start off by looking at our function, y equals x squared. With the function y equals x squared, in the previous lesson we learned about h's and k's. H's being those left-right shifts, and k's being that up-down shift for our parent functions, or for our functions in general. In this parent function, it is good for you to note that our h comma k is equal to 0, 0. This is very important as h comma k is always our vertex. So hk is our vertex. So that means that our vertex is going to start at 0, 0. So 0, 0 is what we're going to place in the middle of our table when we're endeavoring to graph it. So this will always again be our h and our k, which is our vertex. From there, we're going to come up with x values that are around at -1. So around the 0. Smaller than 0 is -1 and -2. Bigger than 0 are 1 and 2. From there, we're going to fill in our table of values. So if we were to take our x value of -2 and plug it into our equation here, we'd have y equals -2 squared. And that gives us a 4. So this output is a 4. If we plugged in our -1, we'd have y equals -1 squared. And -1 squared is 1. So our output is a 1. If we were to plug in our 1, we'd have y equals 1 squared, which is 1. So this output is a 1. And lastly, if we had y equals 2 squared, that gives us 4. So this output is a 4. So we've come up with at least 5 order pairs that are going to be on the graph of y equals x squared. So let's go ahead and graph those 5 order pairs. So you have -2, 4, which is here, -1, 1, 0, 0, 1, 1, and 2, 4. Notice that it makes a U shape, which it should because this is a quadratic, and quadratic functions make U shapes, which are also called parabolas. So we have a parabola here, and that's our parent function. Key thing to note about this parent function is that its vertex is here at 0, 0, and these are the common points that are used or are a part of our parent function, y equals x squared. These being those points: -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Okay, our domain. Our domain, remember, that's going from left to right. For the parent function, as well as for quadratics, this is going to be all real numbers. Another way to write that would be -infinity to infinity. So 2 different ways to write that for the domain. The range for each of these problems is going to vary. They'll be different based on the bottom towards the top, or the bottom towards the top. So we'll have an inequality to represent our range for our quadratic functions. So if you're looking from the bottom to the top, the bottom y value, the smallest y value here, is our 0. So therefore this range is going to be y is greater than or equal to 0. because 0 is the smallest y value for this graph. And going upwards, we're going to constantly grow and grow and grow because of our arrows. So the highest value will be a positive infinity, but we'll write that as y is greater than or equal to 0. As for our end behavior, remember that you have a left end and we have a right end. The left end will have, as x is going towards negative infinity, our y is going towards, and then we fill in our blank. So on the left, we're going up, up, up. So we're going towards positive infinity. Our right end is as x is going towards positive infinity. What's happening to our y? So that's on the right. So on the right over here, we're going up, up, up. So then our y's are going up towards positive infinity as well. Okay. So as far as bonuses, again, for your quadratic functions, bonus features is a vertex. So that's the point that's in the middle of your u. And you also have something called an axis of symmetry. The axis of symmetry is a vertical line that goes down the middle of your parabola. And in other words, it splits it into half. It gives you an axis of symmetry. What's on the right-hand side matches what's on the left-hand side. And that axis of symmetry in this particular case is x equals 0. So if you zoom in a little bit and we look in the dead middle, we have this represents our axis of symmetry. And in this case, this is when our x value is equal to a 0. So your axis of symmetry will always be x equals the number that the middle line crosses through on the x-axis. All right, so using all of that background information, we're going to go ahead and interpret some quadratic graphs. So find the indicated information for each graph. Think about how each example compares to the parent function. Okay, so one thing that we know for sure about the parent function is that our original vertex is here at 0, 0. If you locate the new vertex on your parabolas within your graphs, this will make your life so much easier. So here's our new vertex. So notice the original vertex for our parabola would have been at 0, 0, but we've shifted and now our new vertex is here. So when we're thinking about transformations, we can follow the vertex around. So from 0, 0, we're now going 1, 2, 3, 4 to the left. So we have a shift left of 4. And our new vertex is 1, 2, 3, 3 up. So we have an up shift by 3. So you had a shift left 4 and a shift up by 3. Okay, and those are our transformations for this particular problem. If we're thinking about the vertex, our vertex is just, well, what is this ordered pair? This ordered pair is the point negative 4, comma 3. So the vertex is negative 4, 3. The axis of symmetry, well, let's split this in half. And if it's split in half, we are going through the x value of a negative 4. So the axis of symmetry is x equals negative 4. The domain for your quadratic functions is always all real numbers. Our range is the one that varies. We need to look at going from the bottom to the top. The bottom of our parabola here is at a y value of 3. And then our y values above 3 are all covered. So therefore our range is y is greater than or equal to 3. The end behavior will have our two statements. As x goes towards our negative infinity, y goes towards, and we'll be filling in our blank. And the other one, as x goes towards positive infinity, our y goes towards blank, and fill in that blank. So x is on the left, so x is when they're negative. When the x's are going towards the left, we are going up, 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 up with our graph. So therefore, we're going to positive infinity. And as your x's are getting positive, that's going towards the right, we are going to positive infinity as well. And we're done with number 1. Number 2. Let's again remember that the original vertex is at 0, 0 for our parent function. But here's our newest vertex. Well, let's see what shift has been made. So we've gone down by 3. So one transformation is down 3. And then how do we get to this point from here? We would also have to move over by 4. And we're going over by 4 to the right. So right 4. So those are shifts. Notice another shift. Our parent function is usually sitting upwards, up and opening up like a cup. But this parent function, this function here is facing downwards. So therefore that's a reflection. So another transformation is that we have a reflection. Okay. All right, next we look at our vertex. Where is the vertex? Vertex is the highest or the lowest point, or you can call it the bending point, or it's the point that's directly in the middle of your U. So in this case, our vertex is at 4, negative 3. So this is a point 4, negative 3. The axis of symmetry is simply going through the vertex, and it's the x-coordinate of the vertex, which is 4. So x equals 4. Domain, once again, always all real numbers for your quadratics. And then the range, we're looking at our y's, possible y values. So notice that the top of this graph is up here at negative 3, and then everything below it is covered. So in this particular case, we're going to have a y value that is less than or equal to our negative 3. So all of the y's that are smaller than or equal to the negative 3 are a part of our range. In behavior, remember there's 2 statements. As x goes towards negative infinity, y is going towards fill in the blank. And as x goes towards positive infinity, y is going towards, and again, fill in the blank. So as x's are going towards the left, our graph is going down. So we are going to negative infinity. As we are going towards the right, our graph is going down. So we are once again going down towards negative infinity. Okay. Let's try one more together. So remembering that the original vertex for your parent function would have been at 0, 0. But our vertex is up here at 1, 1. So first off, noting from 0, 0, where the original vertex for the parent function would have been, we now must shift over 1 to the right and 1 up. So those are 2. Right 1, up 1. Okay. Also noting that this parabola is opening downward, this means that we have a reflection. Okay. The next thing to note is that our vertex here is at 1, 1. The axis of symmetry goes through the vertex, and we're looking at the x-coordinate for it. So x equals 1. Domain will always be all real numbers for your quadratic. And then the range, we're looking at your possible y values. So notice that this one does not go above 1. It's every y value that's below your 1. So you will have y is less than or equal to 1 as your range. In behavior, we have as x approaches negative infinity, our y is going towards, well, as we're on the left, we're going down. So this is going down towards negative infinity. And as x is going towards the positives, our y is doing what? So as we're going towards the right, we are also going down. So therefore, this is going towards negative infinity. All right, you try numbers 4, 5, and 6, and then you're going to pause the video. After you've finished, unpause, and then check your answers. All right, and here are your answers for numbers 4, 5, and 6. Please check your work. All right, so we're going to move on to the cubic functions. And we're going to start off by looking at the parent function for cubics. So the parent function will be y equals x cubed. So this is the very basic of our cubic functions, y equals x cubed. Okay, we're going to start off by doing the same thing. We're going to identify, instead of a vertex in this case, our h and our k. It's called a point of inflection. So we're going to identify that point of inflection. So if you can remember, the general form of your functions and your equations is f of x equals a times x minus h, and then plus that k. So in this case, we're looking for the h and the k. So notice that there is no h and there is no k within our parent function. So think about the defaults once again. It's just 0, 0. This helps us to find out what numbers we should place in the middle of our table so that we can graph our parent function. So 0, 0 goes in the middle. And then we come up with numbers that are around 0 for the x's. So that will be -1 and -2 going backwards. And then 1 and 2. So notice that these are the numbers in order. -2, -1, 0, 1, and 2. The next thing we do is plug each of our x values into our equation so that we can figure out our outputs. Okay, and we are showing you the long way of how to do this. And then soon you'll learn the shortcut using the calculator. So y equals plugging in -2 cubed. This is the same thing as -2 times -2 times -2, which is equal to -8. So this first value is a -8. The second one, you have y equals -1 cubed. That's equal to -1 times -1 times -1, which is equal to -1. So this is -1. The next one, you have y equals 1 cubed, which is 1 times 1 times 1, which is 1. And then the last one, we have y equals 2 cubed, which is 2 times 2 times 2, which is equal to 8. So this is 8. Lastly, or next, we'll plot our points. And when we plot these points, they should look something like that saddle that was referenced in lesson 1. And it's here. So that's our cubic function, and that's the parent function. You should note that the point of inflection is here at 0, 0. And our points are around it. -2, -8, -1, -1, our 1, 1, and our 2, 8. That's our parent function. So remember that we can have shifts to the left, shifts to the right, shifts to the left, shifts up, shifts down. We can have stretches. We can have that this gets wider, etc., etc. When we think about our domain for our cubic functions, the domain will always be all real numbers. The range will always be all real numbers. Our end behavior as x is going towards the left, so negative infinity. Our y's, in this case, so towards the left, we're going down. So we're going towards negative infinity. As x is going towards our positive infinity, our y's are going towards, so positive infinity, that means we're going towards the right. We're going upwards, so we are going towards positive infinity. That's our end behavior statement for our parent function. Okay. So again, remember that our bonus feature for cubics is that point of inflection, and it's 0, 0. It's very similar to your vertex. This is where we begin to kind of make a shift for our graph. So let's interpret a few of our graphs. Remember that the point of inflection for our parent function cubic is at 0, 0. Our point of inflection for the graph we're looking at is here at 1, 3. So this is our point of inflection, 1, 3. The shifts or the transformations that have been made, we went from 0, 0 over to the right by 1 and up by 3. So those are our two transformations. So right 1 and up 3. Okay. When we think about the domain and range, they're always all real numbers for both. The end behavior as x approaches the left, our y's are going down towards negative infinity. As x approaches the right, our y's are going up towards positive infinity. Okay, for the next one, remember that the original point of inflection will be at 0, 0, but this one here is at the point -2, -3. So -2, -3. So when you're thinking about the transformations, we've gone over to the left by 2, and we've gone right by 3. I'm sorry, we've gone down by 3. There's one more thing to note. Usually our parent function goes up from left to right. This one is going down as we travel from left to right. So this is a reflection. Domain, all real numbers. Range, all real numbers. That's the case for all of your cubic functions. And then our end behavior as x is going towards the left, our y's are, so let's look at it as we're going towards the left, we're going up with our graph, so we're going up towards positive infinity. And as x is going towards the right, our y's, let's look at it, towards the right, we're going down with our graph, so we are going towards negative infinity. Okay. For number 3, go ahead and pause your video and try it on your own. And here are your answers. So our point of inflection was at -3, 2. Our original point of inflection would have been at 0, 0. So we ended up shifting left 3 and up 2 as our transformations. Domain and range are both all real numbers. And our end behavior as x is going towards the left, so as we're going towards the left, our line was going down, so that's y is going towards negative infinity. And as x is approaching the right, our graph, our line is going up, so y is going towards positive infinity. The last part of this lesson is going to be how to graph these functions and then pick out that same information that we've been coming up with in all of our previous problems. The domain, the range, vertex, axis of symmetry, as well as the end behavior. For this one, we have a quadratic. F of x equals x plus 1 squared plus 3. We can identify the transformations, and then we can go ahead and create a chart or a table, and then graph, and then again fill out our information. I will post a video, a separate video that shows you how to generate the table by using Desmos.com. So please stay tuned for that particular video. But the very first thing is, let's look at our equation, and let's go ahead and pick out those transformations. So for this one, we're looking at our A, our H, and our K. So A, H, and K. A here, we have nothing there. So remember that the default is just a 1. That means no changes have been made with the A's. Your h here, we have a +1. So h equals a +1. Remember that an h of +1 means that we had a left shift by 1. And then we have a k value, and I'll use a different color. You have a k value of 3. So remember that a k value of a +3 means that you went up by 3. Okay, as we are creating our table, we're going to use our h and our k to go directly in the middle of our table. And that's going to be your first step for these problems. So h and k goes in the middle. Since we had a left 1, this is the only one that's a little tricky. It's always when you're placing your h. So we know that in our equation it's a +1, but your h is actually going to be a -1 in your table, and your k is 3. So h and k is -1 and 3. From there, we're going to come up with x values that are around your -1. So going backwards, we have -2 and -3. And going forwards, you have 0 and 1. From here, you're going to end up using your calculator just to save you some time with actually plugging in each of the numbers and coming up with the outputs. You're going to use your calculator, and again, that video will be forthcoming, but for the rest of the problems, I'll simply be filling in the values. Okay. And here are our values. From there, we go ahead and graph. And as you're graphing, make sure that you plot your points correctly. If you notice, this is a quadratic, so quadratic should come out as a U. If your shape does not come out as a U, then go back and check your points. Make sure that you plotted them correctly. Okay. Our domain for our quadratics is, again, all row numbers. For our range, this is where it varies. We're looking from the bottom to the top. So the bottom of our graph is at a y value of 3, and then everything above it, all the y values above it. So this would be y is greater than or equal to that 3. Our vertex goes directly through the middle. I'm sorry, that's not the vertex. The vertex is here. It's our point in the middle. So in this case, it's -1, 3. So it's -1, 3. The axis of symmetry goes through the middle, and it goes through the x coordinate. So in this case is x equals -1. And then you have your end behavior. As x goes towards the left, your graph is going up to positive infinity. As x goes towards the right, your graph is going up to positive infinity. And we're done with that problem. All right, so trying another one. Number 2 is once again a quadratic. First off, noting your transformations. In this case, you're looking for your a value first. Nothing is there. It's defaulted as a 1, so no changes. Second, you're looking at your h. Your h is a -2, so that means that you had a shift to the right by 2. Lastly, your k is a -1, so that means that you had a shift down by 1. Okay, as you're getting ready to graph, in the middle, we're going to place that h and that k. H and k. The only tricky one is the h. We see that our h is a -2 here. It's going to be the opposite, so 2, and then the k, which is a -1. Okay. Choose values around 2. So 2, going backwards, we have 1 and then 0. Going forwards, you have 3 and then 4. With decimals, you can come up with the values for when you plug in 0, when you plug in 1, when you plug in your 3 and your 4. For the purpose of this video, I'm just going to go ahead and plug them in or give them to you. And one thing that you should notice at this point with your quadratics, whenever you have a quadratic, the middle point is in the middle, 2, -1. All of your y values are going to start mirroring each other. So you have a 0 here, 0 there. And a 3 up at the top, 3 down here at the bottom. So Sometimes if you get that these come out as weird numbers, you automatically should know that something is wrong. All right, next step, go ahead and graph. All right, so we've graphed it and we have our U shape. Domain, once again, all real numbers. Range. Our range, we need to go ahead and look at the bottom to top. Our bottom number here will be a -1 for our y's. So this is going to be all of the y's that are greater than or equal to -1. Okay. Your vertex. Vertex is your middle point, which in this case is 2, -1. Which again, you can think about it, it was here. That's your h and your k, 2, -1. So vertex is 2, -1. Axis of symmetry goes through the through the x value or x coordinate of the vertex. So then that's going to be x equals 2. Your x-intercepts and y-intercepts, those are two that we haven't talked about yet. But the x-intercept is just where is your parabola crossing over the x-axis. And here it's crossing over at 1 and 3. So we'll put the point 1, 0 and the point 3, 0. The y-intercept is where does it cross the y-axis, and that's here. And that's the point 0, 3. Your end behavior as x goes towards the left, your y is going, well, we're going up, so we're going towards positive infinity. And as we're going towards the right, our y is going up towards positive infinity. All right, number 3 is a U-chart problem. Please pause the video and try the problem out. All right, and we have your answer for number 3. So the one transformation that we have is that it's going to be wider than the parent function. In the middle of our table, we should have placed 0, 0 because the h and the k of our equation is 0 and 0. Coming up with numbers around 0, we have -1, -2, and then on the other side, 1 and 2. Using Desmos or plugging in your values for x, we'll get these outputs. We've graphed it, and then we've answered our questions on the side. The domain is all real numbers. The range is y is greater than or equal to 0. Your vertex is 0, 0. Your axis of symmetry is x equals 0. The x-intercept is the point 0, 0. The y-intercept is the same, the point 0, 0. And then we have our x equals 0. It is very important that you rewatch the video, rewind the video if necessary so that you can pick up on the different patterns for each of these problems. But as we move on, we're going to look at a few cubic equations and just simply how to graph them, which is exactly the same as how we would graph the quadratics. Again, we are picking out that h and k, placing it in the middle of the table. But for the first problem, we are going to pick out our transformations. In front, we have our a value. Our a is a -1. So this means that we're going to have a reflection because of the negative. Next, we're looking at the h. Our h is a -1. So this means that we're moving right by 1. And then notice that your k is missing. So that's a k, a default of 0. So we don't have any transformations here. We're not moving up or down any. In the middle of our table, once again, you place your h and your k. So in this case, remember h is the tricky one. H goes the opposite of what you see up here. So h was -1. In our problem, we're going to place a +1 and then our 0 there. For our x's, come up with the x's around this 1. So going backwards, you have 0 and -1. Going forwards, you have 2 and 3. Use Desmos to come up with the rest of your values. I'll fill them in for you. Alright, so we have our table. Remember that this one is a cubic function, so seeing that mirrored effect is not the same, or it's not the same as your quadratic. So be very careful that you're looking at your tables from Desmos or your graphing calculators carefully. or make sure that you do your calculations by hand carefully. Okay, next, graph it. Alright, so notice that we have that reflection thing going on. From left to right, it should have been going up if it was the parent function, but this from left to right is going downward, so that's the reflection. Notice that we've moved to the right by 1, so that point of inflection would have been at 0, 0, but now it's here at 1, 0. So that, remember that that's the two transformations that we saw would happen based on the equation. Okay, our domain is all real numbers, and our range is all real numbers for cubics. Our point of inflection is the point 1, 0. Our x-intercept, well, on the x-axis, we cross here at 1, 0. And our y-intercept, we cross right here on the y-axis at 0, 1. Our end behavior, as x is going towards the left, our y's are, our graph is going up, so that's to positive infinity. And as x is going towards the right, our y's are going right, we're going down with our graph, so we're going towards negative infinity. Alright, for number 2 here, let's go ahead and pick out our transformations. Our a value is simply 1. It's not there, so no shifts or changes have been made. Our h is equal to 2, so that means, and it's a positive 2, so that means that we have moved left by 2. And our k value here is a negative 1, so that means that we have moved down by 1. Let's go ahead and place our h and our k in the middle of our table. Again, h is the tricky one. It's an h equals 2. We have to put the opposite number here, so negative 2. And then k is negative 1. K always stays the same here. Okay. Developing our x values around negative 2. Going backwards, you have negative 3 and negative 4. Going forwards, you have negative 1 and 0. From there, fill in your f of x column by using Desmos or your graphing calculator. I'll fill it in for you. Alright, so we have negative 4, negative 9, negative 3, negative 2, negative 2, negative 1, negative 1, 0, and 0, 7. Go ahead and graph it. Alright, so once it's graphed, it should again look like a cubic function. If it does not look like a cubic function after you've graphed it, then please go back and check to make sure that you have plotted the correct points. Our domain and range for cubics, again, both are all real numbers. Our inflection point is the same as our hk, which is here. It is the point negative 2, comma negative 1. And in behavior, as x is going towards the left, we have that y, well, our graph on the left is going down, so towards negative infinity. And as x is going towards the right, we have that our y is going up, so it's going up towards positive infinity. That's our in behavior statements. All right, number 3, which is the last problem within this within this lesson, is a U-try problem. Go ahead and pause your video and fill in all of the information that's necessary to answer this question. All right, and here are your answers for number 3. We had f of x equals 2x cubed. Our a value is a 2. Our h was not there, so it's defaulted as a 0. Our k was not there, so it's also a 0. So when you're going to write h and k into the middle of your table, 0, 0 should be in the middle. And then the x is around the 0. You have negative 1, negative 2, and then 1 and 2. So it's very similar, it's like filling in a number line there. When you went to use Desmos, you should have come out with negative 16, a negative 2, 2, and 16. But then when you went to graph, you may not have had enough space on your graph. So therefore, I kind of estimated where the 2, negative 16, and the 2, 16 would have been. And I kind of drew a rough sketch of the cubic function here. Domain and range for cubics are both all numbers. The point of inflection is 0, 0. The x-intercept, that's where was our line, or where was our cubic function crossing over the x-axis. It's here at 0, 0. Y-intercept is exactly the same. And then we have our intercept. And that's all for this lesson.